So the next one is...
Our next team is the team named Murobo.
Murobo.
Hi everybody.
Hello, wait for a second that I am going to share the screen here. So all right. Can we start with our presentation?
Sure, let's go for it. Lift off.
All right. So, hello everybody. We are a team Murobo composed by me, Donato Brusamento, and my colleagues Josué Severino and Federico Oliva. All of three of us are from the University of Bologna, and we knew each other from there, from automation engineering. Unfortunately, Federico Oliva is not here at the moment because he is at a marriage, not his though, so someone else's. So our project is for Let's Connect is called NetQB, which is going to be pronounced as NetCube. And it's a way that we devised for aiding astronauts and robotic manipulators in the on-site space assembly during assembly operations as a means to... scusate se... Qualche problema?
Sì, la presentazione non è aperta.
Oh.
We can see it. It's perfect.
Can you see my presentation?
We can see
io vedo lo schermo con tutto
it's not full
quanto.
screen, not full screen, but we see it.
Okay. So let me just share the whole screen then, so it's easier for everybody.
Non stai facendo la presentazione, stai facendo vedere PowerPoint.
Okay, so now you can all see your slides, right?
Oh, yes.
Yeah, we were seeing already. No worries.
All right. Okay, so let's...
Okay.
Full screen.
Let's continue. All right. So this NetQB is basically a system to aid in transportation of pieces of parts, for example, for an assembly in the on the site of the space assembly in consideration. And its purpose is to help astronauts or robots to manipulate these pieces, especially when they reach a certain dimension and weight that could be difficult to manipulate otherwise. So we devised this little cobots, a collaborative robot, which is based on a CubeSat for the motor control unit that you can see on the top part, which comprises of a magnetometer for location, some thrusters, actually 8, one for each vertex, for locomotion and orientation in space. And then you basically have a lower part which is made of elastic membrane made of rubber that can shrink or expand at will, so to envelope or release pieces that the cobot can then move around or position in desired places and desired orientation. The features of this robot is the small dimensions, really reduced dimension, because it's at most 50 centimeters long, but it can also be quite easily, it's also quite easily scalable, so you can make it actually larger or even smaller if you wish. It's based on a magnetic positioning system that we devised, that it is not dependent on the Earth magnetic field, but is rather dependent on a local magnetic field made by a beacon. And this sleeve also features an array of sensors, all radially distributed and distributed for the lens, that can be used for understanding how is the piece grasped, and can be used for a diagnostic. And it can also be used for multi-agent collaboration. So if a piece is too big, of course, more robots can go into it, grab it, and manipulate it. So this is an explicative slide, so you can see very roughly sketched the pressure field, for example, when grabbing an object that has some edges on the top and bottom part, and with that data, the system can understand how is the piece rotated, and so it can actually be better at this task by putting it in the desired orientation without any further help from the outside. This is the magnetic beacon that we devise. It's just a simple electromagnetic device like a solenoid that just produces a magnetic field that oscillates. So it's different from the Earth magnetic field as it's stronger and has a different frequency. So you can actually have more areas of the same site in which more robots are controlling from different masters, which can have a very interesting application for multi-robot collaboration. So yeah, you can see here a render on the bottom part on how an assembly site will look with this solution. So you can see here a couple of small robots going around, grasping a piece and orienting it in a certain configuration. On the left side of the slide, you can see what we devised as a docking station, because another point of force of this system is actually the complete autonomy to go to this docking site to recharge the thruster or the batteries whenever it's needed, reducing a lot the aid from a human collaborator, for example. So to be absolutely of just help and not burden on any operator, or actually be able to be feasible to integrate in a complete robotic environment.
Cool.
And
That's amazing. Thank you
yeah.
so much.
Last but not least, just the last point is that everything that we've done is everything commercial component made. They're all easily materials to find and to obtain. So it's really, the feasibility analysis has been very thorough. So we think that this device can actually have a real application. It can actually be realized in real life. So thank you, everybody. This is all for Murobo.
Thank you so much.
Thank you everybody.
Vi aspettiamo al prossimo video di NASA Space App Challenge Brescia.